Please subscribe to Likhitha H YouTube channel and press the bell icon to get early notifications on my latest YouTube video updates. What's up guys, welcome back to my YouTube channel Code to Create. In today's video we're going to classify the types of rice. Let's look into our data set. We have the Arduino, the basmati rice and so on. Let's just look into their images. It's image classification project. You can see we have the different sides of it, the different shapes and everything. All the possible ways, and we have it for basmati and the same way we have it for the others. Let's begin with our coding first. We're going to import our necessary libraries. So I'm going to import pandas, spd, and then we're going to import TensorFlow. And let's import OS for splitting our data set in all these. Then let's say from TensorFlow dot keras dot preprocessing dot image import image data generator. I'll say you guys why you need this. And then let's import model selection. From model selection, let's import train test split for splitting our data set. So let's say from sklearn.model_selection import train test split. Yes. And then let's import matplotlib. Then let's import image grid. I'll say you guys why you need all these libraries. I'll show you guys. And then from pathlib, let's import path. So I'm going to say from pathlib, import path, and then from PIL, let's import image. So let's say, I'll show you guys why you need all these, don't worry. Let's import CV2. Then let's import layers, keras and preprocessing because we need all these for our model. So let's say from TensorFlow.keras. This is for creating the layers. So let's say layers. And then let's import keras. That's pretty much not necessary, so let's just ignore it. And then from sklearn, let's import preprocessing for processing the data. Let's run this. Let's continue. And after this, let's just say that image link is equal to, and what we're gonna say now is we're gonna create a list of all these links, like all these images that are there. We're just gonna create a link for this. It's basically like we're gonna have the path on where it is. So let's just say image_link is equal to list of paths. Here you go. You have the path, and now we're gonna get all our images. We're just gonna take this. We're not gonna select a particular one because here what we're gonna do is we're just gonna get the path here of what it is. So we need the whole link, and after that let's do a few other things for getting the path. Let's say dot, and now what we're gonna do is we're gonna get the link here. You can see you have separately for the image itself, and you're going to say .jpg. Now let's come down and let's say image name, what type it is, basically the label. And then let's say image name is equal to x dot. I'll explain it to you guys what this is. Dot stem for x in image link. The name of whichever image it is, And now we're gonna get the label of the image. Equal to pre-processing dot label encoder. This is the encoded one, and the image name is for which the one which is not encoded. Let's fit this image name into this. Okay, sorry. Yeah, let's run these now. Now we're going to create a data frame out of all of this. So let's say df is equal to pd dot data frame of all this. So we're going to say df of link, is equal to np dot array image link, comma, and the data type of this is we're going to convert into a string. I'll show you guys why we need to convert into a string. I'll show it to you guys. And then let's say df of name is the image name, and df of label is equal to image label. Let's see a data set now. Okay, n b is not defined. Okay, we must have not imported it, so let's just say import numpy as np. Or you know what, let's just, rather than running the whole thing again, let's just get it out from here and import it over here. Let's say import np. Yeah, now let's see a data frame. Yes, and this is converted to a string, as I told you guys, the name of the rice, and the label for it, which is encoded. Now let's see a plot of all these value counts. So I'm going to say df dot name dot value counts to see which one has the lowest and all those things. Let's see that. Here in this plot we have to set the figure size or it's going to be messed up, and we need the grids. So I'm going to say grid is equal to true, in color let's put it as, yeah. Now let's run this. Yes, wait, let me make it a bit small. Yes, now you guys can see the whole thing. And as we can see, we have all the data sets equal, like number of basmati rice, all of them are equal. We have now equal number of samples. And now we're going to plot another plot. I'm going to show it to you guys. I'm going to say fig. Okay, let me make it a bit big. Yes, is equal to plt dot figure 1, and the size of it should be 15 by 15. And then let's say grid. Here we're going to use the image grid. Let me show you guys. 121, and the number of rows and columns is, the number of rows it has 5, and the number of columns it has 4. And then the access pad, let's set it to 0.10. The iteration for this, let's set it as 0. Let me show you guys. After I run it, I'll show you guys the plot. For now, let's just continue with the code. I'm going to say for category, ID, category, we're going to split them into two, for category ID and category in enumerate. It's basically a function type df name, and let's get the unique value of these. Let's say for file path in df of name, we're going to get a particular column. We're going to say is equal to category And then let's put another bracket, another square bracket. Let's say link dot values, and let's till the fourth value, let's get all of them, all the values from link. And then let's say ax is equal to grid of I. Now we're going to begin the iteration. We're going to say x is equal to grid of I, image is equal to image dot open. Let's open the file path. Then let's say ax dot image show the image. This, what we're going to do is, it's going to be really surprising, and we're going to write this big code just for getting all the images that of the rice, like all the different types of rice we have them, right? We're going to get the label and the below. Let me show it to you guys. It's going to be more confusing if I say it to you guys. So let me show you. Start access of if I percent type 4 is equal to 4 minus 1, then access, ax dot test 300, sorry, let's just get 300 100 category, and the vertical alignment let's put the alignment to center, and the font size to 20. Sorry, the font size, sorry, this is supposed to write like this. Yes, font size to 20, and the color to red. Let's go back. Let's say I is equal to plus 1. Let's say I plus is equal to 1. Now let me show you guys the plot, or to be in particular the image. So I'm going to say plt.show. Let's run this. It says a name error, that is name not defined. Which line? df okay, we're not gonna say df comma, we're gonna say df dot, I'm very sorry, this is df dot name dot unique. It says another access has no attribute test. From which line? That's text. Okay, now let's run this. This should work. Let's just yeah, we have them here. We have 4 of each type of rice, and now what we're gonna do is we're gonna split these things, split these folders, so we get the train and test data set. So I'm gonna say import split folders. Did we import them already? No, let's import that. Folders split folders dot ratio. Let's get the same link. Okay, I have it up, still copied. I'm gonna say comma output is equal to comma c is equal to 101, and the ratio it is equal to, I guess this is supposed to be in parenthesis. Let's just see. The ratio is supposed to be in 8:1:1. Let's run this. Invalid syntax. So let's try with the square brackets once. Now let's run the same thing. Oh, okay. Let's just try putting a comma here. I guess that should work. Now, sums of ratio is over 1. It is supposed to be like dot. Sorry, I missed the dot. Dot. and it's supposed to be in parentheses. This is another mistake. Okay, let's run this. Okay, till it copies the files, let's just continue with our code. Let's divide this now. Let's say train df comma test data frame is equal to train test split df test comma test size. I'm gonna set it to 0.3. How much it should divide between the test and train. And let's say in random state, let's set it as 1. Let's run this also. And now what we're gonna do is we're gonna train these images. So what I'm gonna say is train images is equal to image data generator the flow from data frame and now I'm going to say the data frame that we're going to give here is for the train data set. So we're going to give train df and the x column, let's say it as link, the y column is name. We're just setting our x and y column here, and then let's set the color mode to RGB. Sorry, the batch size to 32. The target size how much it should be. What is the target over here? The size of it. Sorry, what is the target over here? The size of it. That's 28 and 28 from both the sides. Let's say class, and we're gonna set the class mode to categorical. Categorical. And the subset to training, as this is, and as we have set it as train images, we're going to set the subset to training. Now what we're going to do, we're going to copy almost the same thing. We're going to copy this first and we're going to do the same for the test, other than the thing that we're going to change here test images, and here it's going to be test df, the same 32 RGB 28 28. We don't have the subset here. Let's run this also. Let's keep moving till it gets completed. You can see it's still here copying the files. Let's run this also. Let's continue to our model. Here we're going to use sequential. So I'm going to say model is equal to df.keras.models dot sequential I'm gonna say we're gonna do this the same thing. What we're gonna do is we're gonna get cont2d, we're gonna do max pulling here, and then we're gonna repeat this, and then we're gonna flatten and then dense. Okay, so let's do that. We're gonna say layers cont2d 16 comma 3 and let's set the input shape to 28 28 3, and then let's say activation is equal to real. Now let's do the max pooling. So I'm going to say tf.keras.layers.max pool 2d. So I'm going to repeat this another time. Let's copy this. Okay, come down, paste it up. here we're going to change it to 32. And the input shape is not there as we have already put it. And now we're going to say tf.keras.layers.flatten .keras.layers.dense activation is zero. We're gonna do the same with different numbers. Let's see. Let me show you guys. What I got mine. Now let's copy this. Here we're gonna put 128. And 5. And here let's set the activation to softmax. No, it's still continuing. Okay, let's just continue with our code. And now we're going to compile our model. So I'm going to say model.compile. Optimizer is Adam. The loss is categorical entropy. If it's only two things classification is like 0 and 1, you can select binary cross entropy. So here it's more than 2, it's 4 of them. So we're going to set categorical cross entropy. And the metrics, we're going to set it to accuracy. And then let's fit our model. So I'm going to say model.fit. And now let's fit our train images. So I'm going to say model.fit train images. And we're going to set their fbox to 3. And after this, let's evaluate our test images based on these train images. So I'm going to say model.evaluate test images. The training and testing images are done. Now let's move to the model. Let's run this. TensorFlow, that's already imported, right? TF. Not What's wrong? Okay, we forgot the comma. Now let's try. Line number 3. Don't find any mistakes. Okay, we need another comma. Again. It is from the layers here or this. I don't. .keras.layers.max 2D. Invalid syntax. This is right. This is also right. All of them. Okay, let's just try this. Maybe this will work. Let's try. It still says the same error. That okay, yes, we forgot to put the comma. Now it'll work. Yes. It's okay. This is ILE. Let's run this and let's evaluate the test images. It's done now, and for evaluating it's still running, and we have to go for 704. It's in 207 somewhere there. You can see it's running. Let's see our output. Let's wait for some time. Yes guys, even evaluating the test images is done. Now we know how to predict or classify the types of rice. That's great. Thank you guys. Please like, share, subscribe and comment below. Bye bye.